Hello, today we're going to be looking at an introduction to developing and deploying applications to the Windows IoT core running on Raspberry Pi 2. If you followed along with our previous video, you have seen how to install Windows 10 for your Raspberry Pi 2. So now we're going to follow up with showing you how to get started building your own applications and how to kick those off to your device. So we're going to start by heading over to windowsondevices.com. That's all one word, windowsondevices.com. And we're going to go ahead and click on the Get Started page. From here, we're going to select the Raspberry Pi 2. And again, you're going to want to make sure you've completed all the steps for setting up your device. I'm going to briefly talk about getting your PC set up, but we're not going to go into too much detail due to the time involved with getting this set up. But it's pretty straightforward. Make sure you've got Windows 10 installed. You have Visual Studio 2015 Preview, the Windows IoT Core project templates, and ensure that you've enabled developer mode on your Windows 10 development machine. Once you've got your environment configured, you can go ahead and hop over to step 4, the develop. We're going to hang out here for just a little while, but just wanted to take it aside and tell you what we're going to look at today. So this is going to be an example of a Hello World application running on the Raspberry Pi 2 with a full user interface. So classic Hello World. We're also going to have a blinking light, so your classic Hello World for the world of IoT, where we're going to be actually interacting from Windows IoT Core through the GPIO pins, controlling a physical device. This is going to be really interesting stuff. So all the code that we're going to be diving into is going to be located here at github.com/ms-iot/samples. Again, that's github.com/ms-iot/samples. So once you're there, you will see the GitHub repo, and we're going to go ahead and download the zip file. So over there on the right-hand side, we'll go ahead and click Download Zip. If you're interested, you can also clone this repo and submit pull requests or even add new samples to the collection. So if you've got some cool ideas, feel free to contribute. This is an open source repository. So with that downloaded, I'm going to go ahead and open it, and we'll extract this over to my desktop. So real quick, before you get started, make sure you do have your Raspberry Pi 2 running Windows, and that is configured, connected to the same network as your Windows 10 development machine. So you're going to see when we deploy, it's very critical that we're able to find the device on the network. So make sure that you have all of this configured before proceeding. Once we have this fully extracted, I can open up the samples developed folder, and we're going to get started with the Hello World project. You'll see this is a C# project. We'll go ahead and click on helloworld.csproj, and this will open up in Visual Studio 2015. We're going to go ahead and uncheck the Ask Me for Every Project in the solution box and click OK. One of the first things you're going to notice, this is an IoT project, but we've got XAML here. So this is the user interface language that's been used in Windows applications for a long period of time now. And we can actually interact with this very easily using the designer tools within Visual Studio. So if you need to mock up a user interface for something you want to build for Windows IoT Core, you can do that right here. And due to this being part of the universal Windows platform, technically, this code could actually be transferred over to a Windows 10 application or Windows Phone application. So you'll see we've got nothing really crazy going on here, just regular old XAML with a grid, stack panel, text box, and a button inside there. Really interesting, though, if you think about this in the world of IoT, because we can actually create buttons that could do things like adjust potentiometers or even change digital values, instead of having to create some sort of a hardware interface to adjust those. So we can actually rapidly prototype some of our ideas a little bit quicker by taking advantage of this user interface. I'm going to go ahead and expand this and take a look at the code behind. You'll see that there's not really anything interesting going on here, except that when we click the button, it's going to change the text box message to say, Hello Windows 10 IoT Core. So let's go ahead and deploy this guy. First, we need to make sure we're building for ARM, since the Raspberry Pi 2 does use an ARM architecture. And second, we're going to go over here to the device, and we're going to change this to remote machine. Now, my home network doesn't seem to pick up my device, so I'm going to go ahead and configure this manually. And that's not too difficult to do. What we'll do is right-click on the Explorer, open this up, and I'm going to go ahead and head to C, Program Files, x86, Microsoft IoT, and open up the Windows IoT Core Watcher. So with this opened up, you can see we have a MinWinPC board name that's available on the network with an IP address of 192.168.1.35. Any of these values is valid to use for the manual configuration. I'm going to just opt to choose the board name. So we'll type in MinWinPC here. And then for authentication mode, I'm going to select none. Then we'll hit the select button. Everything should be configured appropriately now. And I'm going to go ahead and hit the deploy button. So this green play button up at the top says remote machine. Go ahead and click that. And this will build the project and then send it over to the device. So this should take just a few moments for this to get sent over. Now while this is going on, you'll notice that this does have a button, so we can actually interact with this using a mouse. I've got this cool device here, the Mini. I have a link to where you can pick this up. It's about $15 on Amazon. I love this thing. It's a portable keyboard and mouse combination in one. And notice I'm actually going to plug this receiver in while the code is booting, and it's going to actually pick that up. So at runtime, you can go ahead and add your USB devices and peripherals. And once the application has started, I'll make sure to turn on my keyboard, I can then interact with it using the touch mouse here. And we can go ahead and click this Click Me button. So you'll see currently it says Hello World. Might be a little hard to see on the screen. I'm going to go ahead and issue a click. And you'll see that that changes. So I'm actually interacting with a program running on the board through a USB peripheral. It's really interesting, cool stuff, right? So let's jump into a bit of a more exciting example. For those of you wanting to do IoT things, you're probably wanting to get into circuitry. So let's look at how to blink a light using the Windows IoT Core. So back within our Hello World project, I'm going to back out to the samples develop folder. And you'll see an example here called Blinky. I'm going to go ahead and open that. And we're going to choose the C# version for right now. So the CS folder, and open up blinky.csproj. And again, I'm going to uncheck the Ask Me for Every project in the solution and hit OK. Now this particular example actually follows along with an example that's available over on windowsondevices.com. So you can, if you need help making the circuit and that sort of thing, there's R here on the develop example. So if you get to step 4 over here, this is actually the same code. It's walking through using the Blinky example. And again, I've got my main page XAML. And this is going to be a very simple user interface that's going to essentially showcase a light on the screen. It's going to simulate it, whether it's turning on or off, right? So it's currently gray, but it'll flash gray and red onto our screen once we deploy every 500 milliseconds. And again, this is some basic XAML here, grid, stack, panel, ellipse, text block. And this sets up the user interface for the particular demo. Over in the C# code behind, you'll see that we are initializing an LED pin on pin 5, and I'm going to go into a bit more detail about this. We're using something from the windows.devices.gpio namespace to give us the GPIO pin and the pin value. We're also leveraging some useful .NET types like the dispatcher timer, and we can also interact with the user interface using the solid color brush. So within this code, it's a very basic example. We set up the dispatcher timer, and we call timer tick every 500 milliseconds. And we set up the GPIO by calling init GPIO. Inside here, we have the GPI controller.getDefault. This basically tells us that there is a GPI controller available on the device. And we then set the pin value to high, write that, and we initialize the GPIO pin. The logic for the code is very basic. Every time timer tick is called, we look to see the value of the GPIO pin. If it's high, then we go ahead and set it to low. Otherwise, we set it to high. So simply toggling a light back and forth. So going back to the example, I do want to highlight up in the code where it says LED pin 5, this actually maps to GPIO pin 5 on the pinouts for the Raspberry Pi 2. And this is not one-to-one, so you don't want to look at these and count 1, 2, 3, 4, 5, because they don't necessarily match to the physical pin layout, as you'll see. So physical pin 1 gives us 3.3 volts power, right? and then physical pin 29 gives us GPIO 5. So what we need to do here to simulate the circuit, we're going to have an LED, and very basically we've got a long end, which is the cathode, and the short end, which is the anode. I'm going to make sure to have that cathode attached to the voltage line in, so that's going to be this red wire that's going to pass through a resistor to protect the LED from burning out. And then this is going to be our control line, the black cable here. So what I'm going to do, similarly as they've done here, is tap into the 3.3 volt power supply over on pin 1 using the red cable. And then we need to be on GPIO pin 5, which is actually the 6th from the left. So I'm going to go ahead and count that left top rail. That is 1, 2, 3, 4, 5, 6. And I'm going to go ahead and plug that in. We can quickly test that our light bulb is working properly. Since we have voltage in, and we can see here that pin 39, the ground, is on, we should get a light bulb turning on just by connecting to the ground, right? But we want to actually get this on a GPIO where it can turn it on and off. So again, I'm going to go 1, 2, 3, 4, 5, 6. And we'll go ahead and plug this in. Now, if we deploy this code, we should see this toggle the light on and off every 500 milliseconds. So again, we're going to click on device, select remote machine. I'm going to type in minwinpc, turn authentication mode off, hit select. Ensure that we're building for the ARM architecture, and then deploy to the remote machine. I've already got this app installed, so it's going to ask me if it wants me to override it. I'm going to go ahead and select yes. And this is now beginning the deploy of the application over to the device again, as we saw before. So hopefully everything is wired up correctly, because if so, then we should see our light begin to blink as the code flashes every 500 milliseconds. In addition, we're going to see that user interface. It actually should be almost in synchrony with the light bulb. And this is interesting to think about because you've got sort of a visual indicator, right, on what's happening with your circuit. And there's a lot of interesting ways that this could be used, either for testing while building up a circuit, or for even creating something that we have yet to see, right? So you'll see my light is flashing, and it's doing it in synchrony with the circle that's flashing gray and red on the user interface. So cool stuff, right? And again, we're leveraging the full power of .NET within here. Just a few things to note. In order for this to work, to interact with the GPIO pins does require that I use windows.devices.gpio. And I do have a reference to the Windows IoT extension. Again, I'm going to go into more detail on how to set up a project from scratch in our next video. But for now, just to make you aware of how this is working, those are the necessary references and namespaces that are required. So let's go ahead and look at the same example, but this time using C++. So again, another cool thing that the Windows IoT Core can do is it runs .NET. So we actually have availability of multiple languages here right outside the box. So I'm going to go ahead and click the Blinky example and hit CPP, and we'll go ahead and open the Blinky cpp.vcx proj. So once this opens up, it's going to be exactly the same. A few things that you should notice. We'll go ahead and uncheck the box, click OK, is that we have XAML with C++. So this is something that was introduced back in the Windows 8.1 days when universal apps were first announced. And you'll see that that carries over into the Windows IoT Core. And I can go ahead and, just like we saw before, I've got my visual editor here, and this XAML is going to look exactly the same. There's basically no difference. In fact, I don't think there really is anything different between this XAML and the previous XAML we were looking at. It's going to be a grid, stack panel, ellipse, and 2 text blocks. So it looks exactly the same, right? And the code behind for this is in a CPP file. And very similarly, you're going to see again that we have the namespace to Windows Devices GPIO. And you'll see over here in our references that we also have the Windows IoT extension SDK. This allows us to speak to the GPIO pins. The logic is exactly the same as our previous example. We set up a dispatcher timer. We have the init GPIO that grabs the GPIO controller to initialize it appropriately. And every 500 milliseconds, we toggle the state of the LED. Now, one thing that I did notice was a little bit different with the C++ projects was how we deploy this over to a remote machine. So by default, you will notice that this is targeting x86. We're going to go ahead and switch this over to ARM in the drop-down. And the remote machine, although that's given to us by default as a selection, it's not been configured. So in order to do that, I can right-click on the project, hit Properties, go into Debugging, and then we have this section here for machine name. You could also use the IP address here. So I'll type minwinpc, as we did before, and require authentication, we'll set that to no. Similarly, if we wanted to do this with the C# project, say for example, we misconfigured it and we wanted to go ahead and change those credentials on how we're sending over to the remote machine in a C# project, we would do something very similar. We'd go ahead and open, and once we have the project available, we can right-click on the project, and it's going to look a little bit different. You'll notice that the interface we're given is not exactly the same as the one we get for C++. We'll click on Debug, and here I can change the remote machine and also make sure that authentication is turned off. So just a little FYI there. And from here, if everything is configured correctly, we should be able to just hit Remote Machine, go ahead and rebuild the project, and this should deploy into the device as we saw before. So we'll just wait a moment for that to happen. So we've got our build going. And it says, cannot start without a machine name. Yikes. So it looks like the properties didn't stick there because I didn't hit apply. So we'll go ahead and hit minwinpc again and hit require authentication no and apply. Okay, and then we'll go ahead and deploy again. Deploy succeeded. So we should see the same exact result. We're just using a different language this time. So we've got C++ running on Windows IoT Core, blinking an LED in just a moment. While that's firing up, I'm going to go ahead and take a look at our next example by launching up Internet Explorer. You may have noticed in our previous video that there is a web interface that runs on Windows IoT Core that has a variety of different things that we can use. So remember, the IoT Core Watcher showed us that our board is online at 192.168.1.135. And I'm going to go ahead and hit port 8080 to attempt to log into the device. And we're going to need to use some credentials to get in here. So it's going to need administrator with a capital A as the username and password using an @ and a 0, an @ for the A and a 0 for the O. So that's password. Again, I'll bring that up in my text document. You'll see our C++ code has deployed appropriately, and we've got the blinking light running. So you've got user, administrator, and P password, right? And I'm going to go ahead and log in here. We'll go ahead and stop this program from running. And once I'm logged into the interface, and this should always be running on the IP address port 8080, so make note of that, right? I'm going to go ahead and click on Apps. And this brings us into the AppX Manager. You can see all of the applications that are installed on the device. You'll see the Blinky example, the Blinky CPP example. And we can actually kick those off from here or even make it the default program to run when we turn on the Raspberry Pi 2. So what I'm going to do here is show you how to deploy a pre-built binary through this web portal. So you might have someone who has some code and they want to share it with you, right? You've got everything set up. You want to run it on your Raspberry Pi running Windows IoT Core. Very simple. So I'm going to jump back into the Blinky CPP project. We'll go ahead and hit Project, Store, and then hit Create App Packages. And from here it's going to ask, do you want to build a package to upload to the Windows Store? I'm going to select No. Hit Next. Make sure that we build for the ARM architecture. So you're going to make sure that ARM is checked and go ahead and click Create. And this will take a minute for this to build. And boom, there we go. Shows us the output location at app packages/Blinky CPP. I'm going to go ahead and copy that path that it output to. And if you're not sure where that is, it's always the project folder, and then it will be in a app packages folder. So you'll see, like, here's my Blinky example, CPP app packages, right? And then inside there, we've got the AppX upload and our test folder. So this test folder is where the stuff is that we're going to use to upload. So I'm going to go ahead and copy that, head back into Internet Explorer, and you'll see to install an app, I need the AppX and the certificate. So I'm going to go ahead and click the Browse button here, paste in our path from previous, and I'm going to double click on the AppX, and then similarly head into here and click on the .ser file. So again, that's the .cer, that's the certificate file. Go ahead and click that. If you do require dependencies like external DLLs, you can go ahead and add those using this button here. If you've got everything set up, you can go ahead and hit the deploy button, and this will deploy that code onto the device. It is saying it's failed to commit the pending deployment, and the reason is because we've already got this installed on the device. So again, I can click up here on Blinky CPP, hit the remove button, and this will remove that from the board. And then we can go ahead and hit the deploy button again. So just wanted to show you that in case you do get that error. That does indicate that you've already got the application installed on your device. So we'll wait a moment, and it says install complete. Do you want to reboot for changes to take effect in the shell? We don't need to reboot. I can just go ahead and hit cancel. And now you'll see Blinky CPP is back in there since we just uploaded it through the web portal. I can select it and hit the start button, and boom, it kicks off automatically over here on the Raspberry Pi 2. So we've looked at quite a few things here in this video. You do now know how to deploy an application through Visual Studio as well as the web portal. And we've also looked at a quick introduction into how the C++ and C# apps work on the Windows IoT Core. What we're going to look at in the next video is how to create an application from scratch. So we're literally going to do File New to create an IoT Core project. And this one's going to be pretty fun, so you might want to stay tuned for this. We're going to actually simulate clicking on a Samsung Galaxy S6. So we're going to cheat on one of those idle games, right? You ever see those games where you click the cookie or touch the button to get points? We're going to simulate rapid clicks using a relay, some tinfoil, and a cell phone, and we're going to drive it through a user interface program that we're going to deploy onto Windows IoT Core on our Raspberry Pi 2. This is really cool stuff. I'm very excited about this. You've seen that we've got user interface on here, full power of Visual Studio. We can actually debug on the device, see running code. We can ship already compiled code. It's just really, really cool environment for getting started with IoT. So if you do have any ideas, I would definitely encourage that you guys send those over. I am taking requests for particular projects, and I'd like to see what you guys are coming up with. If you've built something, please share that. We'd love to see what you guys are doing with the Windows 10 IoT Core. So until next time, happy hacking, and enjoy your development work for Windows running on IoT.